When the question says factor, you're given an expression, and your answer should be an expression. But if instead I had come at you with the question, not factor this expression, but solve this equation for x. In other words, get x by itself, figure out what values of x make this equation balance. Well, then I would have had to have given you an equation in the first place. So let's make it an equation by putting equals 0. So now we have a different problem. But, and this goes to the question of the day, if I know how to factor the expression that's on the left-hand side, that will give me a way to solve the equation. X squared minus 11x minus 26 is equal to 0. We know now that we can factor the left-hand side as x plus 2 times x minus 13. And therefore, I'm going to move this up a little bit here to give us some room. We have an equals 0. We have on the left-hand side x plus 2 times x minus 13. But now we can't be satisfied. We're not done yet, right? Because we haven't finished solving for x, if that was the original question. So pay attention to the original question. This is something that often nips math students in the butt. If you don't read what the question is asking you to do, sometimes you do something that's completely correct, but it's not the right thing for the problem. Right? Solve for x means let's find out what are the values of x which satisfy this equation. Factoring has gotten us one step along the way. But it only helps us if we can do something else with it. And that something else is the reason that we factor in the first place. The reason that we factor in the first place is that it lets us do what we're about to do. It lets us take this equation, which is equal to 0 on the right-hand side. So having it be a 0 is super important. If you try to do this and the right-hand side is not 0, then you are doing something illegal, invalid, something that's going to not get you to where you want to be. But because it's a 0, but because the right-hand side is 0, we can split apart these two factors. Give each one of these factors its own equation. X plus 2 is equal to 0. X minus 13 is equal to 0. And then solve each one of those equations on its own, which, because each one has only a single power of x in it, we knew how to do this weeks ago. Add 13 to both sides in the second example. X equals 13. So factoring is our main tool for now to solve equations that have polynomials in them, specifically polynomials of degree 2. Those are really going to be the only ones that we learn special techniques for how to factor. And once we've factored an expression, if it's a participant in an equation whose other side is equal to 0, then we can split, give each factor its own 0, solve each simpler equation, and thereby get the solution of the original.